I'm Dan Navon. I'm an associate professor of sociology here at UC San Diego. And I think that's about all I have to say about that. You'll get to know me a little bit through my presentation. So I'm going to use my talk today to get at what I think are some potentially pretty radical developments at the intersection of genomic medicine and patient advocacy. And I want to show how a mutation like the one that we see here, indicating a missing chunk of DNA, can actually transform the way that we approach a person's illness, developmental difference, and identity. And the same goes for any other genetic test indicating any other sort of pathogenic mutation. And so these days we all have some sense, I think, of the profound role that patient advocates and activists play in biomedical research and treatment. They raise money, they raise awareness, they fight for services, and sometimes they even intervene in the process of biomedical research itself. But today I want to argue something a little bit different. I want to argue that the right sorts of patient advocacy can transform what it means to have a genetic variant or a genomic mutation. So what do we mean when we talk about rare mutations, right? Most pathogenic variants or mutations, right, changes in our DNA that we think are associated with disease, are very rare, or at least quite rare. But taken together, they're actually quite common. And so what happens is we have lots of people out there who are undiagnosed, who have a genetic condition, but either haven't been diagnosed yet, or perhaps they never will be. And it means that they and their family often go through what's often called a diagnostic odyssey, this very stressful experience of getting lots of different clinical diagnoses, but not really knowing what's the underlying cause. And it's important to keep in mind that even though individually most mutations are quite rare, cumulatively, they're very common, right? There are millions of people out there with genetic diseases, some of them diagnosed, most of them we think probably not diagnosed. And there's also a lot of very poorly understood genetic difference out there, right? When it turns out when you look at lots and lots of people's genomes, you find lots of different things going on, mostly things that we don't quite think are eligible to be kind of called or put in a patient's medical record, but that there's reason to think there might be something going on. And so, in other words, there's no shortage of rare genetic difference out there, even though the individual differences are quite rare in themselves. And so my goal today is to show how a new kind of patient advocacy, when it's combined with the right kind of biomedical research on genetic mutations and variants, is starting to really reshape medical classification, patient prognosis and care, and actually the very meaning of genetic difference. And I'm going to show how in some instances these genetic diagnoses can even blur the boundary between the normal and the pathological, right? People who we say, you know, you don't have to go to the doctor anymore, you're fine, and people who we say we want to keep following you up, maybe treating you, et cetera. And I'm going to be speaking especially about diagnoses that are associated with neurodevelopmental differences, right? So things like autistic spectrum disorders, intellectual disabilities, things like that. And then I'm also, towards the end of the talk, going to argue that this kind of sort of change in the way we think about genetic difference creates new opportunities, but also dilemmas as we move towards eras of mass prenatal and newborn genomic screening. In other words, as we move towards an era when perhaps many or even most babies and also fetuses will be subject to some pretty serious genomic screening. So first, we're going to talk about the way that genetics can remake medical classification, right? So what do I mean by that? Most of the time when we think about what genetics is supposed to do, we think about the gene for model, right? The gene for diabetes, the gene for this, the gene for that, right? In other words, there's an existing medical condition and we find a genetic change that can explain it. But that very rarely works, right? This kind of image we see of glimpsing into a baby's future isn't the scientific reality, right? Genetics can maybe tell you about risk, but it's very rare that you get a kind of one-to-one alignment with a genetic change and a kind of clinical diagnosis. Instead, we see something quite different. We see that a lot of biomedical experts and patient advocates now have moved towards a genetic reclassification of disease. In other words, they discover, delineate, and diagnose disease strictly according to genetic mutations, and sometimes in the face of enormous phenotypic heterogeneity, right? That's just a fancy way of saying even when the people who have the mutation have lots of different kind of presentations, lots of different problems, lots of different kind of levels of the kinds of problems that they're dealing with. And so this is what I call the genomic designation of disease. And if you look at sort of the recent history in the genetics literature, you're constantly seeing papers like this. Papers reporting a mutation that's never been seen before, or a variant that's never been seen before, and kind of saying, this doesn't really line up with an existing thing, so we're going to call it a new disorder. So we see papers like this, the list goes on and on. There are now thousands of these. And so even though the gene 4 model rarely works, there are now thousands upon thousands of genetic diagnoses out there. But most of them wouldn't exist, at least in the form that we understand them, if we didn't know the underlying genetics, right? Genetics reclassifies rather than just kind of explains medical conditions. In other cases, mutations are used to kind of recalibrate, lump, or kind of split together or split apart or lump together existing conditions, right? Even when we do make an association, it tends to be quite complicated, right? You have to do a lot of reclassification to make the genetics really line up with the way that we're different, the way that we might be ill or disabled or whatever. And so some of these conditions, right, these what I call genomically designated conditions, are extremely rare. Others are more common, but cumulatively, again, it's important to keep in mind these things are not rare at all. Some of them are consistently severe, some tend to be mild, and others range from dozens of serious symptoms to no clinically significant effects at all. And so what does it mean to have one of these mutations, right? That's what I want to talk to you about today. And of course, just to give away the punchline, I'm going to argue that patient advocacy can revolutionize what it means to have a genetic mutation. We think of it as fixed, as kind of determinative because it's in our genes, but actually what it means really depends on the social worlds in which a genetic mutation is kind of made to matter. And patient advocacy is probably the most important factor in all of that. And we can tell that if we go back in time, because actually, we've been doing this, right? We've been finding mutations and carving out new medical conditions for over 60 years, right? All the way back in 1959, there was this famous discovery that trisomy 21, or 3 copies of the 21st chromosome, caused Down syndrome, right? And that was a rare instance where the gene 4 model kind of worked, right? You had an existing condition. It was called Mongolian idiocy at the time. We call it Down syndrome now, or trisomy 21. And they discovered a genetic explanation that lines up pretty well, not perfectly, but pretty well. And this was enormously exciting for this young field of cytogenetics, right? And this early field of human genetics. And immediately they started saying, okay, well, we found this, but just a few months later, they start finding other changes, right? Other trisomies. They found females with 3 copies of the X chromosome instead of 2. And they found people with 3 copies of chromosome 13 instead of 2. So that led them to delineate what's now called trisomy X, was for a while called superfemale syndrome, or trisomy 13, what's often called Edwards syndrome. And it's interesting because even though these were the first 2 kind of examples of this way that genetics was used to reclassify medicine, trisomy X is about as mild a genetic disorder as you can get, and trisomy 13 is about as profound, right? Most people who have it don't survive early childhood. And so by the early 1960s, there were already a plethora of these genomically designated syndromes that had been reported in major journals. If you were a geneticist trying to make a career, finding one of these things and reporting a new syndrome could be a total game changer for you. You'd publish in the Lancet, the New England Journal, all the top places. But as soon as they started finding these abnormal genomes, and most of the time they didn't line up with existing conditions, they started to delineate new syndromes, right? Trisomy X, trisomy 13, 5p minus. There was a whole host of these things that have now been around. We've known about them. We've understood, at least to some degree, their genetics pretty well for around 60 years now. And this goes all the way back to these early aneuploidies, when you could see whole chromosomes being duplicated or deleted under the microscope, down to single nucleotide variants, so single base pair changes in the 3 billion base pairs that make up the human genome, found via whole genome sequencing today, right? When geneticists find new things that don't line up with existing conditions, they very often kind of delineate these new syndromes. But for decades, these new diagnoses had very little impact outside of the world of human genetics, right? Again, you could make a career, but it didn't go that much further than that, right? It might explain a person's congenital abnormalities, developmental differences, but that's about it, right? For several decades, there was very little reason for a clinician to order postnatal testing. Back then, very few people outside of human genetics really cared all that much about these syndromes, and there wasn't that much you could do with them, right, to help a person or their family deal with the things that were troubling them. A genetic diagnosis just didn't gain traction with experts in other fields, never mind with patients and with publics, right? It was very much kind of confined to these human genetics journals. The one major exception was males with an extra Y chromosome. So here we see an early report in Nature on what came to be known as XYY or super male syndrome. And here we see the front cover of the New York Times from 1968. And this is this kind of famous story of a sort of misadventure in human genetics where they went out into prisons and asylums and they found all these men with an extra Y chromosome and they associated it with mental subnormality, as they called it, violence, criminality, and so on. And it turned out that once you looked more broadly, it was much less clear what XYY meant, right? It was a kind of disaster for the field that they had been so quick to kind of take what's known as ascertainment bias, right? The bias that comes from where you look for things, and really, really kind of going to town with what the likely implications were. And yet, if you fast forward to recent years and you look up XYY syndrome, you might find something more like this. A patient advocacy brochure of a pretty happy family with a kid who, certainly is not mentally subnormal. He's not destined to be a criminal, but he might be more at risk of certain conditions like attention deficit hyperactivity disorder. His IQ might be just a little bit lower than his unaffected siblings and things like that. And so this gives us an initial hint, right? The phenotype of a mutation, of a genetic mutation, depends on the world it inhabits. Right? So let's take another case of what I call genomic designation, this practice of using genetics to carve out new medical conditions. This is a condition known as Phelan-McDermid syndrome or 22q13 deletion syndrome. And so research on this chromosomal deletion at 22q13.3, it's just where it is on the chromosome, begins in the 1980s. There's just a few patients identified by this researcher, Katie Phelan. And yet, by the early 2000s, there had been parent meetings, and 22q13 deletion syndrome had been kind of declared as a standalone condition in a major journal, despite what Phelan herself called the lack of a recognizable phenotype, right? Again, the idea is this is a new important medical condition, even though it doesn't really point to something very specific. In fact, quite the opposite. The 22q13 deletion syndrome Foundation was established in 2002. And today, the renamed Phelan-McDermid Syndrome Foundation is a vibrant group, right, of patients, parents, activists, along with a bunch of allied experts, including Katie Phelan, but also a number of others. They have an alliance with Autism Speaks, the main autism advocacy organization, and they now have ongoing pharmaceutical trials. And so the 22q13 deletion, right, the same mutation, has gone from this quarter-page report in the American Journal of Human Genetics to a really important diagnosis underwritten by a vibrant community of patients, families, activists, caregivers, experts, and more, right? And so today, when a kid is diagnosed with 22q13 deletion syndrome or Phelan-McDermid syndrome, instead of it just being something that's in their medical record that doesn't mean very much at all, they might get something like this. A booklet with a parent's guide to living with Phelan-McDermid syndrome. This is a booklet specifically for parents who've just received the diagnosis. The booklet contains a letter from a mom talking about how they're going to be welcomed into this community and this family. And then it also gives them, and this is just the first 3 of about, I think, 12 or 15 pages, a series of steps they should be taking in order to plan for life with a kid with this genetic mutation. What kinds of early intervention services to look for, what kinds of clinical follow-ups they should be pursuing, what kind of specialist care team they should be building, and many, many other things. And beyond just sort of helping families, the foundation has really tried to transform the terrain for research on this condition. So they've established what they call a data hub. This is a combined kind of biobank and registry where patients can upload their genetic data combined with really detailed descriptions of the challenges they face, what's helped, what hasn't. And if you think about it, if you're a biomedical researcher, would you rather study something where you would have to, call up colleagues at hospital after hospital trying to find caseloads, or would you rather study something where there's an existing data set of 1,000 to 2,000 kids with all of the information there ready to access, and of course, people who are eager to follow up if you're interested? I think the answer is clear. And so with these kinds of resources, with the alliances that they've built with experts, with the fundraising that they do, 22q13 means something very different now. Not only are they're sort of this rich phenotype, this very detailed set of things that we now associate it with this condition, There's also a whole kind of website dedicated to medical advisories, all of the different things you should be looking for and doing for your child. There's fact sheets with different things you could be doing. There's EU-approved guidelines for treating Phelan-McDermid syndrome. And there's also a series of pharmaceutical trials underway, largely motivated by the idea that if you can figure out how to treat autism in kids with this specific genetic version of autism, you might unlock the key to at least some subset of the autism population more broadly. Because we know the genetics of this condition, perhaps it will help us unlock the secrets, again, to at least some portion of the autism population. And yet, around the same time that she discovered 22q13, the same geneticist, Katie Phelan, discovered another chromosomal change called 2q37, I believe, which hasn't given rise to any of this, right? It's in the literature now. You can look it up. But there's no foundation, there's no database, there are no trials. And I asked her in an interview how she might explain that. And she said to her, the answer was clear. These early patients with 22q13 were really frustrated with their existing care and diagnoses, and they sought to kind of organize and mobilize, whereas the 2q37 parents really didn't. And to her, that was the difference. Not the phenotype, not the prevalence, not any of that stuff, just the activism of this small group of parents working to change the lives for their children. And so patient advocacy can transform the meaning of genetic difference, right? That's what I want to try to convince you of today. And so today we have these alliances of experts, patient advocates, and others who are transforming what it means to have some of these conditions, right? Again, there are thousands of these conditions, and most of them don't have anything like the kind of infrastructure of 22q13, right? But some of them do, a growing number. Some of them have built these kinds of alliances, communities, and movements, and we see here just some of the logos from some of the major patient foundations associated with these genetic changes. We see the Phelan-McDermid Syndrome Foundation up there on the right, a host of others. And again, some of these have been around in the medical literature for over half a century. And yet, it's only in the last couple of decades with the kind of rollout of patient advocacy that they've achieved anything like this kind of power and meaning to the people who have them. And I'm going to spend quite a bit of time in the rest of the talk talking about this example of the 22q11.2 deletion syndrome and its foundation. So groups like these are working with experts to kind of leverage their connections to common conditions like autism, as I discussed. And instead of just being these kind of almost throwaway things in a patient's medical record, right? Maybe they can explain something, but they don't really go beyond that. They now have rich phenotypes, right? When you read about one of these conditions, there's a lot of very specific things that we now know, or at least think we know about people with these changes that would have been unthinkable if it weren't for these communities. There are patient databases and biobanks, there are treatment guidelines, there are specialist clinics, and in a growing number of cases, there are now pharmaceutical trials as well. And so today, right, in contrast to when these mutations were first discovered, finding a mutation can remake a patient's prognosis and their identity. I talk about all of this and more in my book. There it is, Mobilizing Mutations, the name of the talk today. It was published a few years ago with the University of Chicago Press. As far as I know, it's available in very few bookstores, good or otherwise, but it is easy enough to find online. If you want a discount code, ask me afterwards. And so the book shows how genomically designated conditions started flooding the biomedical literature beginning in 1959, but also how they had very little impact on patients for the next few decades. I explore the way these mutations and the people who have them have been leveraged as kind of precious biological models for more common issues, aggression and delinquency, language and sociality, obesity, and above all, psychiatric conditions like schizophrenia and autism. It shows how these alliances of researchers and patient advocates turn these genomically designated conditions into richly detailed, important medical conditions and patient identities, and how these mutations and conditions are starting to change clinical thinking and practice, and sometimes even what counts as illness or impairment in the first place. And then finally, I look at these mutations today as genetic testing expands and patient advocacy movements gain steam, but also as they've become the main target of a new wave of non-invasive prenatal genetic screening, a development that has far-reaching potential and that I'm hoping I'll be able to touch on at the end of my talk. So let's talk a little bit about this other microdeletion, 22q11.2. It's actually quite common. It's found in at least 1 in 2,000 people, although some estimates are as high as more like 1 in 1,000. And 22q is really highly variable. It's been associated with over 200 clinical symptoms, ranging from autism, heart defects, and schizophrenia to constipation and malar flatness, or such a mild phenotype that clinical care is never sought at all. As Donna McDonald-McGinn, one of the leading researchers and advocates for the condition, put it to me in an interview, she said, 22q is 22q. It's a spectrum from no symptoms to every malformation under the sun. And so 22q might be extreme in its kind of clinical heterogeneity, but it's not an anomaly, right? And so a group of parents and genetic counselors started a support group around a kitchen table in Philadelphia in the early 1990s, and that has since blossomed into this extensive network of advocacy and activism headlined by the International 22q11.2 Foundation, say that 10 times fast, with their motto of detection, no grow. They recently changed their motto. And so the 22q deletion has gone from a candidate gene for this rare condition called the George syndrome into this really, really important new genetic diagnosis, again, underwritten by this vibrant kind of community. There are now specialist clinics all over the country and, in fact, all over the world. There are specialist management guidelines. And so a 22q diagnosis can really reshape treatment and care in a way that was just completely unthinkable not all that long ago. Here's a map of some of the clinics. Again, we can see they're clearly clustered in North America and Western Europe, but this kind of rollout of clinics all over the world. And so a 22q consortium published a grand rounds in the Journal of Pediatrics in 2011. And the foundation who'd actually helped to organize this, they took out an ad in that same issue, specifically trying to get pediatricians to think about ordering tests for 22q. And they had the guidelines translated into several other languages. And if we look at this kind of key table from that grand rounds, again in this leading journal, the Journal of Pediatrics, we see how no less than 21 specialist assessments are recommended for people with 22q, regardless of their presenting signs, and often at several developmental milestones each. And this is important because with all of this scrutiny, you often find things that otherwise would have been missed, things that start to blur the boundary between the normal and the pathological. I'm going to go over this quite quickly, but what this shows here is that they've actually created standalone growth charts for people with 22q. And if you look at infants or people up to the age of 3, this is the first 36 months of life, we see that most of these kids with 22q are at the very, very low end of the growth spectrum, right? Most of them actually qualify for this very serious failure to thrive diagnosis. But when we shift our perspective from the first 36 months to the first 20 years, we see that these kids mostly catch up, and in many of these bands actually overtake what's called their kind of normative counterparts, right? And so the very concept of normal growth has been transformed for people with 22q. And this comes up all the time if you go to a 22q Foundation meeting or if you talk to families. It's at once a call to action, especially in those early years, but also a reminder not to worry too much about their low growth compared to non-22q populations. And so when you talk to families, you start to see how this stuff really matters to the way that they navigate their healthcare systems. So patient advocates draw on these resources, right? The foundation helps create them, but then parents take them back to their local healthcare centers and their local pediatricians to help get these referrals and treatments that don't look like they're clinically indicated, right? Based on what the patients are actually like. And so I was talking to a 22q mom, and she put it like this about her kids' medical team. She said, well, they trusted me because I knew about 22q, and I would tell them all about that. I usually could walk in there telling them, okay, this is what the findings show. I mean, I would walk in with the literature, just like I did for the diagnosis with human growth hormone deficiency. They said, oh, he's way too young to have that. It's not soon enough. And I said, he's not on any growth chart that you've got. And sure enough, they found 2 problems. Or when I walked in and told my pediatrician they're now recommending cervical spine x-rays, he looked back in the charts and said, well, we don't have that. We'd better get that then. And so what we're starting to see is that these kinds of conditions can start to remake the boundary between the normal and the pathological, right? When experts and patient groups start working together, they discover these new and surprising things that you never would have guessed just by kind of looking at the first cases reported in the literature. Genetics is starting to destabilize thresholds of clinical significance developed in other fields. In other words, when a field says, we think at a certain level, there's a problem that needs to be followed up or treated. Sometimes kids with genetics, or parents of kids with genetics are saying, actually, we want that even though my kid doesn't reach that clinical threshold, because the genetics tells us there's a serious risk here. And so Brenda Finucane, who's this sort of very important figure in this field, she was the president of the National Society of Genetic Counselors. The way she puts it at 22Q Foundation meetings, National Fragile X Foundation, a whole host of other meetings, she has this line she uses a lot that I think is very telling. She says, the gene didn't get the memo that 70 is the cutoff for intellectual disability. And what she's getting at here is, if a kid has one of these mutations and their IQ is 80, which means they usually wouldn't be eligible for special services, we should ignore the existing threshold and recognize that they have a deficiency based on their genetics, and we should give them specialist treatment anyway. And we see an example like that here. I've been told I need to stay close to the microphone, so forgive me. But if the standard threshold for intellectual disability is here, most of these kids in blue with this mutation clearly don't meet that threshold. But when you compare them to their parents and their unaffected siblings, what you start to see is this 2 standard deviation, quote unquote, hit from the mutation, right? And so the argument here is very clear. We shouldn't be denying kids these services just because their difference fails to meet this kind of arbitrary cutoff point based on what they're actually like. And so in this way, traits and symptoms that are well within the clinically normal range can be recast as symptoms of a genetic disorder, right? Or they can be split into these kind of subparts that reveal differences kind of buried in what look like normal findings. So one example is verbal or performance IQ, when this sort of overall IQ looks like it's in the normal range. And so instead of this very foundational concept, incomplete penetrance, the idea that a mutation doesn't always have the associated effect, research on people with these conditions is pointing towards what's often called subclinical traits and quantitative spectra of variation, instead of these kind of you have it or you don't, right, based on firm cutoff points. And a paper making just this kind of argument for 22q made the cover of Lancet Neurology a few years ago. And I think this image captures this kind of realignment pretty poignantly. We see a child who's not necessarily sick per se, but just a few steps behind where he should be were it not for his genetic mutation, right? We know from his family background where he should be, and yet the genetic mutation has him not sick, but just not quite where we would want him to be. So what does the future hold for genetics and patient advocacy, right? This is what I want to leave you with. Well, on the one hand, patient advocacy groups and alliances for genetic disorders, these are two groups that kind of bring together lots of these advocacy groups and really do really amazing work. They're going from strength to strength, right? They're getting pharmaceutical companies to take interest in these conditions. They're growing caseloads. They're building animal models. They're doing really incredible things. And there are a lot of people out there who carry pathogenic variants and mutations. And this is important because companies like Illumina, who I should have thanked for sponsoring this event, are making genomic screening and testing more accessible than ever. At the same time, a new wave of targeted gene therapies is finally en route. After years and years or decades of being science fiction, gene editing-based therapies are now coming. Right? We don't know exactly what that's going to look like, but they're in advanced stages of the trials process. Meanwhile, population genomic screening programs are getting underway too, both here in the US. All of Us is very famous. It's us trying to create a database of around 1 million Americans, but also groups like Rady here in San Diego, who are starting to do trials of programs that would screen every newborn baby for a list of several hundred actionable genetic disorders. And so Genomics England is rolling this out potentially nationwide in England or the UK over the next few years too. And so we're going to be finding a lot more people with these mutations in the coming years if these programs do in fact come to fruition. There's also now much broader social acceptance of disability and neurodevelopmental difference in the kind of disability advocacy community, there was a lot of excitement when a Gerber baby who has trisomy 21 or Down syndrome was named in 2018. And that kind of thing really would have been unthinkable a few decades ago. We've come a long way as a society in terms of embracing people with these kinds of genetic and other differences. But of course, I'm a sociologist. I have to look on the downside as well. And there's also a major risk of new medical odysseys and inequalities, right? These patient advocacy groups still face enormous obstacles, right? If you have a kid with one of these conditions, it's often an enormous struggle to get the kind of treatment and specialist care that you believe you need. Right? And so this is something that should not be minimized. As much progress has been made, there's still a long, long way to go. Screening may also reveal new patient populations, right? We generally only run genetic tests on people who look like they have a genetic disorder. And as we start screening more and more people, we're going to find a lot of people who have very mild presentations. And it's unclear how that information is going to impact them. Right? It's going to lead to very uncertain implications for their prognosis, their care, but also a host of kind of healthcare and other costs. There's already a severe shortage of genetic counselors who can help patients and families navigate these difficult questions, of specialist expertise and care, early intervention services, many, many other things that families with these conditions want that are already in short supply. There are also dramatic inequalities by race, ethnicity, socioeconomic status, and a whole host of other factors, right? And so, who's going to have access to genomic screening, right? Who has the healthcare coverage for all the recommended follow-up testing and care? Who's going to be able to demand early intervention services and referrals that don't seem to be indicated by a child's clinical presentation? Right? Who's going to have access to incredibly expensive gene therapies, right? The first ones are hitting the market for something in the region of $2 million, right? And so all of these things mean we need to be really careful that the rollout of genomic screening and all of these important things that come with it don't actually widen existing inequalities, especially in a country like the US, again, by race, wealth, and so on. And so how can we ensure that precision medicine doesn't unleash a cascade of uncertainty and even iatrogenic harm, right? How can precision medicine be prudent and equitable? And there's one final point I want to make in my kind of, downer mode. And that's this question about what the fate of these patient advocacy movements will be in an age of mass prenatal genetics, right? Non-invasive prenatal genetics is this new technology or newish technology where instead of having to do dangerous, uncomfortable, invasive genetic testing during pregnancy, you can now do pretty sophisticated genomic screening just using a blood sample from the mother. And this really changes the landscape, and especially it changes the landscape in terms of the proportion of pregnancies that will be subject to true kind of genomic screening, right? And that raises some really important questions, right? Because if we look at the brochures for these non-invasive prenatal screens, we see that most of the conditions on these screens are precisely the kinds of conditions I'm talking about. 22q, XYY, XXX, trisomy 13, etc. There's Down syndrome, but the rest of them are these kinds of quote-unquote genomically designated conditions. And so this is going to create deeply uncertain dilemmas for expectant parents, right? Because the truth is, we don't really know what the full range of presentations of people with these mutations are, right? What we know is ridden with ascertainment bias, because we only tend to test people who have the telltale signs. At the same time, we can't tell them much about the fetus, right? Because there's only limited kind of clinical evaluation you can do. And so there's this kind of double uncertainty of what I would call proband and population, right? The fetus and what we know about the condition itself. And of course, because selective abortion is the main intervention that you can do after a positive prenatal genomic screen that's confirmed by a diagnostic test, this may in fact change these populations that are united by genetic difference in a variety of ways. And so what is this going to mean for these patient advocacy movements, right? Who's going to have access to prenatal genomic screening? And who will choose selective abortion when they get a result that's confirmed by diagnostic testing? Who's even going to have access to selective abortion given the ongoing assault on reproductive rights in this country? And for these groups in particular, what will it mean when their patient populations are potentially much smaller overall? and perhaps also less wealthy, less urban, less concentrated in the global north, less religious, and less white. All social cleavages that are already very powerfully associated with access to genetic testing and abortion services, right? And so these kinds of considerations mean that we need to be very mindful of what the famous sociologist Troy Duster has called the backdoor to eugenics, right? This risk that things that are done with good intentions, technologies that are meant to promote health and well-being, can actually turn into things that start to look more like, a genie being unleashed from the bottle, right? Changes to the population, exacerbating inequalities, things like that, that even though no one intended it, may end up being the ultimate result of the rollout of these technologies. And so genetic testing and research can, without question, provide powerful answers to questions about human disease and difference. But what it means to have one of these mutations depends on the work of patient advocates, experts, caregivers, and a range of other stakeholders. These kinds of groups have made incredible progress over the past few decades, turning these mutations from things that barely matter at all to something that can completely transform a patient's identity, prognosis, treatment, and so on, and also provide an important sense of community for a family dealing with the challenges that come with having a child dealing with these kinds of challenges. And so we may be at an inflection point, right, where mass genomic screening and targeted therapies sort of further transform the landscape in ways that overall are very beneficial. But of course, there are competing forces at play and a series of major pitfalls that we need to be mindful of so that we make sure that the rollout of all of these new technologies doesn't end up having these kinds of dangerous boomerang effects. And so the future of genomic medicine is open. And we all need to confront these kinds of challenging questions about what it is that we do with this knowledge about genetic mutations and genetic difference, right? We've seen how patient advocacy and other social forces will decisively shape the rollout of genomic medicine in very fundamental ways. To understand what it means to have a genetic mutation, we need to look at the work of patient advocacy movements, expert activist alliances, biotech companies and health systems, just as much as we look at the role of genes, proteins, and physiological pathways. Only then will we be able to understand how the absence of a bright dot on an image of stained chromosomes or any other genetic test result can mean so much. Thank you very much.
Hello, my name is Carolyn Brown. I am a genetic counselor. Currently, I work at Illumina, but my background before that was in pediatric genetics in the clinic, seeing folks with all different types of genetic conditions. Currently, I work in a laboratory in Illumina that does genome sequencing for rare disease. And basically what I do is I look at people's data and their medical records, and we have a whole process that we go through to try to arrive at diagnoses. So please feel free to ask me anything you'd like.
Hi, I'm Stuart Comer, and I'm with both an undergrad and went to medical school here, so I'm very familiar with the terrain. So thank you for coming here this evening and taking your time to do so. I also work at Illumina. I'm the laboratory director both for the lab here in San Diego and also the one in the Bay Area, which actually performs the Veronata NIPT test. So Professor Navone's discussion was quite interesting in terms of cell-free DNA and what we're doing at the prenatal level. And so along with Carolyn, we also do rare undiagnosed disease testing and have affiliations with, Rades and other facilities so that we can understand and actually try to reduce that diagnostic odyssey. So again, thank you so much for having us.
Hi, my name is Jin Jeong, and I am a postdoctoral scholar at the Institute for Practical Ethics. So what I work on is philosophy of medicine and philosophy of science, the intersection of those two things. My doctoral research was on personalizing medicine or precision medicine, and also the use of race in medicine and considering genetics in medicine as well. And so this presentation and the talk was very interesting for what I'm working on and all of the issues that come up with thinking about the genome, classifying new medical diagnoses by the genome and the implications of this socially, ethically, all of those important topics. Yeah.
Well, great. Well, thank you. And thank you again for you all joining us. I think that the first question I wanted to get started off with is from our audience here. It says, what role should parents have in determining what genetic disorders should be screened for in newborn screening? Is there a role for patients in genetic screening guidelines?
I think Professor Navone actually set that stage very well. So at our lab up in the Bay Area, like I said, we do over 50,000 tests. Now, for a lot of you, you may not realize that this past year, the state of California actually now has allows and supports the financial remuneration for prenatal testing. So for everybody. So to kind of Professor Navone's, that's what they're doing. So ostensibly, the pregnant mothers basically make that determination with their caregivers and are offered that opportunity. And so that's, I think, an extremely important start from this process.
I think I can add to Dr. Comer's point that I think that already exists to some capacity in a lot of genetic testing scenarios, right, where you would have the choice to receive certain information or not. And I think the majority, can't speak for everyone, obviously, but most people in the field, generally support that people should have some control over the information that they might want to receive or not receive. But where it gets really messy is doing that in practice. And I experience that every day looking at people's DNA sequences, because you really don't know what you're going to find until you start looking at it. And I think the other point is you often don't know off the bat sort of what that means. So you can't really tell a person up front, you can opt into this, or you can opt out of that, because it's not so clear cut in practice.
Yeah, just to add to that, it's a very, very challenging question. Philosophically, ethically, you might say everyone should have autonomy about what their child or their fetus is tested for. But in the US and California, we do screen for over 50 conditions through newborn screening without parental consent. Most people don't even know that it happens, because we think that those conditions, you can intervene so effectively if you catch it early, that we have to do it. And it's better that parents don't know so they can't opt out. And we don't know how that framework or that logic might apply in the future to potentially hundreds of genetic disorders that are similarly actionable. And so Genomics England, they're really leading the way on this right now. They're planning for the potential rollout of mass newborn genomic screening. And they've been doing extensive consultations with activist groups, with parents, to try and figure out what people want and what kinds of options they want. But just because it seems ethically clear that we would want to give people autonomy, in practice, it's very difficult, because we do sometimes want to save babies from the mistakes of their children. And it would also be very cumbersome to go through a list of hundreds or potentially more genetic disorders saying, well, we think we know this about that. Do you want this? Check or X. And that's just not feasible. And so in theory, it seems straightforward. In practice, there's a whole kind of gnarl of issues to be dealt with there. But newborn screening suggests at least sometimes policymakers are okay with not giving parents kind of autonomy over that.
To that, I would add that, of course, autonomy is important for parents, but I think what's important to note about genetic disorders, or the whole field of precision medicine, or even looking at like biomarkers for things in cancer, is that sometimes there is some challenges with the evidence in that regard. So even though something may appear to be a genetic disorder at that time, there have been cases where they've been revoked, where it's no longer considered something pathological, for example. And so even though you're testing for all of these things and you may find out that you have them, it may not be the case necessarily that this has any sort of clinical implications or implications for you as a person. So I think the issue there is, what do you do with that knowledge, or what does that knowledge mean? So it looks like looking at the genome can give us all the answers, but it's not necessarily the case that we have all of the knowledge about what do these genomic mutations mean, what are their implications. So I think it's important to also consider the evidence side of things and how strong the evidence is for all of these disorders.
And when you screen for anything, you find a lot of people with the biomarker who don't seem to have the associated problems. And that goes for genetics, and that goes for many, many other kinds of tests too.
Maybe in part interpretation on that question as well you can speak to. I think with the newborn screening, there's historically been variations even by state, right? Relative to cost, relative to perceived ability to intervene to benefit families and kids. And my understanding was always the experts who made those decisions. And maybe this comes from someone who has a sophistication in wondering who sits on those, and does it make sense now as we're rethinking that parents or folks without necessarily expert knowledge with the given disease or its relative, how common it is in the population or medical, is there a benefit to having them on that board, which I think is a complicated question.
In practice, patient advocacy movements can have a profound impact on these decisions that get made specifically about the mandatory newborn screen. That was your question, right? So there are some conditions that the evidence is very clear cut. This was the standard core of half a dozen to a dozen conditions. In terms of this expanded list, the US now mandates 30-something conditions nationwide, and then states can choose to add other conditions. We know empirically that advocacy groups can play a very powerful role getting their condition added to these newborn screens. There's a great book called Saving Babies by Stefan Timmermans and Mara Bookbinder that looks at all of this and the many kind of uncertainties that happen when you expand genomic screening to the population instead of doing testing for people after they've started to show symptoms. Basically, a lot of very challenging clinical and ethical and social dilemmas kind of emerge from that kind of dynamic. And that's where we are right now in the US with a newborn screening system under severe strain because of this expansion in the late 2000s to go from around 8 to 12 to, in most states, 30 to 60 conditions.
This next question from the audience, I think is one that you've touched on, and I think folks are interested in expanding. It says, it sounds like the onus of patient advocacy for certain genetic conditions lies on the parents. However, I can see how a lack of financial means, time, and overall access can prevent parents from starting grassroots efforts. How can we encourage awareness and increase advocacy? And I think, in dealing with parents from all sorts of backgrounds, everyone wants to believe that they're doing the best for their kiddo, and is now the new frontier starting an advocacy group, right, in order to ensure that your kid gets the care that they need.
Well, I would say, and this is interesting because you guys are pretty much early in your professional careers, and I think the reality, I think Professor Navone has kind of set, again, that stage where he realizes that all of us are advocates for this. And to some degree, you are more so because you understand the science a little bit more than other people do. And I think that's one of the issues that comes to fore, is because if you understand that the technological advances are improving, I mean, I would say, Carolyn and I work for a company that is really very devoted to trying to bring genomic testing down so that ostensibly it doesn't become a cost issue. Now, as Professor Navone pointed out, you still have the ethical issues, and we have to have the humility to understand that we don't have all the answers to that. We will continue, from the Illumina perspective, to try to bring the cost down and improve the technology and the accuracy. So it's going to be one of those things that all of us are going to be involved in that, and you guys are going to be part of that equation.
And I would just say very briefly, it's a cliche that a small group of people can change the world. But when it comes to taking a rare condition and really doing this kind of work, it helps if you're rich and well-connected. And there's, in our society, there's no way around that. And so you have these extraordinarily rare conditions that have made huge, huge leaps. And you have others that are quite common. And if there's one big differentiator, it's the involvement of people with what we sociologists like to call a lot of economic, social, and cultural capital, right? The connections, the knowing how to work with experts and policymakers, and money. It matters. Unfortunately, it matters a lot more than it should.
I also would add the notion of reference populations and the fact that what we know about these mutations depends upon the people that we've tested, for example, the genomes that we have. And so if you look at the world, most of the genetic diversity is in Africa in particular. But when you look at whose genomes are sequenced and all of that, it's mostly people in North America and Europe as well. And so I would say when you think about the global south, we need to know more about those populations. There's some ethical issues with that, knowing more and why people don't participate. But I think it's also important to note that what we know so far is based upon who we've looked at. And so if we want to know more, we need to know more about more people. So I suppose things like the All of Us project in the United States is quite an important one, but I think it's also important to look at other parts of the world and how to make these sorts of advances, these technological advances, work in those parts of the world as well. I think that would help the entire world as well. Yeah.
I want to, it's not going to do justice to the folks who wrote the questions out, but I do want to group a few together just to make sure we get through as many of these as possible. And they touch on the issues, one of cost savings, right? In terms of making arguments for insurance companies for coverage, right? You help to improve people's lives, but also cost savings when the testing is actually done is their argument for pushing for earlier testing. And then also the idea of pre-existing conditions and how those variants or mutations or genetic changes get interpreted, both to the benefit of the patient, right, potentially more services, but maybe to the detriment of the patient of carrying a diagnosis for life.
Yeah, I think that's an ongoing issue. I mean, there are laws in the United States and other countries that do protect you to an extent from some sort of discrimination related to your genetic information, but unfortunately that can't predict, if you get a questionnaire and they ask you if you've had a genetic test for X, you have to answer honestly. So I think that is a complicated issue that is, there's some protection in place, but, it's as of yet unsolved, so.
I think it's really neat. I'm seeing a number of questions that get at interest in getting involved, right? Interest in the work. We have folks from, pharmacy, medical, undergraduate, biomedical sciences, or other graduate programs, biology. And I'm curious if each of you all could speak to a little of your own experience and how you got to where you are.
I did my undergrad in anthropology and biology. And I happened to get exposed to genetic counseling actually through a course I took and a project I did working with patients with retinal diseases in the French Canadian population. So that was sort of my first exposure. I love working in the clinic, but I became very interested in the technologies, and I loved working in the space of rare disease and achieving those diagnoses. So that's, as a genetic counselor, you don't necessarily work in a clinic with patients. There are lots of other opportunities. So when a job came up to do genome analysis and interpretation and medical writing, that was a good fit for me. And that's sort of how I ended up where I am. So there's, I guess that's a long way of saying there's a lot of things you can do as a genetic counselor with that training.
And so I basically was a biology major here back in the 70s and early 80s. So when I was here, this was actually a grassy knoll. That's how long ago I was. But, UCSD particularly has always been very well known for its biomedical science. It's actually fantastic. And it's so interesting to recognize now what we were learning at the time. And we had fantastic professors, at the forefront of their fields. But it's amazing how much we've learned in those intervening time. And I was saying to Carolyn, I went to so I basically went through med school here and then did pathology, and went back in my 50s to do a fellowship in molecular genetics pathology, because genetic and genomic testing truly is an essential component to patient care, and you have to have a certain degree of both interest, but also the ability to utilize that for patient care. And increasingly, I look out at you and realize that you guys are the new generation. Think of what you'll be doing 20 years from now, given what you know now, and it's absolutely fantastic. So you're going to be part of that journey for all of us, and I would just say it's incredible, because it's never going to go back, and we just have to have the wisdom to use it correctly, as Professor Navone pointed out. But the technology is moving unbelievably fast. To give you just a quick example, advanced maternal age. My wife had to get amniocentesis to find out that it was recommended, and we did it. But I could have done this test by just drawing blood and have found out the same information and have saved that risk because there's a certain percentage of fetal loss if you do either amniocentesis or cardiac villus sampling. So you look at that and going, that's a technology, and what we want to do is to learn it. One of the things that we test for, in addition to 13, 18, and 21, is we basically test for 5 microdeletions, of which basically DeGeorge's is one of them. Every night I sign these things out, and so I think that's the world you're coming into. We want you to help us advance that. Thanks.
Yeah, well, my first degree is actually in journalism, which is weird. But I've always done philosophy, and in graduate school, my specialization was initially philosophy of biology. So I used to work on the biological basis of race, and then I worked on heritability, and then my PhD was on precision medicine, as I said. So I think philosophy has a lot to offer, many different things in science, in particular philosophy of science, philosophy of medicine, philosophy of race. All sorts of topics that we discuss, they are very impactful, I think, for many scientific fields. And I would like, as a philosopher, to work more with scientists to speak more about the issues that come about in the work that they do. So I think what's important for me is that in the education of scientists, to consider things in the social sciences, things in philosophy that come up in the research that you do and the implications of what you do, thinking more broadly about that. So I think there's lots more that needs to be done about making sure that education is interdisciplinary in that sense for the world that we want to see.
In my many kind of engagements with these communities, these activist groups through my field work when I was doing the research for my book, the thing that makes the most difference for them is dedicated experts, right? In terms of things that you all can do. That ranges from lab experts through to, professional activists and fundraisers, but it's especially the people who really dedicate themselves to these rare conditions that make the difference, right? And so, I met a lot of experts who started off thinking, well, if I study this group, it's going to help give me a kind of biological genetic entry point into studying some common condition like schizophrenia or heart malformations or whatever. But they become part of these communities and they dedicate their careers to these rare groups. And, Illumina is doing incredible work. We're going to be able to sequence genomes, at scale, right? And at low cost. But we don't have the expertise. We don't have the infrastructure to deal with the positive results. Right. Already for the metabolic disorders on the newborn screen, right, there's a crisis. Never mind for the hundreds and maybe thousands of genetic disorders that are going to be diagnosed at much sort of orders of magnitude more over the coming years. And so, I just want to give a special shout out to genetic counselors. They are the glue that holds this together. They communicate and mediate between the parents and the patients on the one hand and the experts on the other. They bring these kind of repertoires of activism, right? Things that these groups can do to help to advance their cause from group to group, right? These innovations that really work, they kind of help spread them around. And so they really are the kind of glue that holds a lot of this together. And, if you want interesting work that combines clinical work, research, and advocacy, but also never being out of a job, I think genetic counseling is the way to go. It's a 2-year degree. We have such a shortage of genetic counselors in this country right now. Just planting the seed for those of you who haven't quite decided on your path yet. I think it's a wonderful thing to do. And kudos to Carolyn.
It's an amazing plug. Thank you.
With that, if there isn't anything else, I want to transition. Thank our panelists.